Hi guys, I wanna solve some of the questions for the practice test which is provided for the mid-semester exam. So the question one is this: the truth table for proving this guy. So we wanna prove that P to Q and Q implies R is P to R. All right. So this means like actually this one implies this one, but we need to say that in the truth table, all of them is the values are truth. So it will be like this one. So we start with the truth table P, Q, R. All right. So we will do PQ, Q to R for sure. P to Q and Q to R using this table and this table. All right. Now, then after we got to do like P to R. Then after we need to do this one. Let's call this guy here A. So you need to write it. So better not to write A. So but because of the lack of space, I have to do that. So this should be A to P to R. So you need to say this through column is all of them must be true. So for this one, you can say T, T, T. So T, T, F. So then after you T, F, T, T, F, F. So you continue. So 8 rows here. So 8 rows here. So you proceed here. So PQ will be T. PQ for this one is again T. Q to R is T. Q to R using this TF, which will be F. For this one here, PQ and Q to R is T. So T and F, PQ, which is this one, and the QR, T and F, it should be F. PR, so I will use this one and this one, which is T here. This one and this one from P in P, if P is true, but if it's not implying truth, then it will be F. So T, F, and you can say that this one is, you see that here, T, T, so this guy is A, T, which implies this guy, so T, which is right, F, F, which is right, T, T. And you continue to complete this truth table, which you will have 8 rows. All right, so let's go to the other question. So for this one, you do the same job, P, part A, truth table for showing this one. P, Q, T, T, F, F. So this should be T, F, T, F. So from here, P, Q will be T, F, T, T. From here, not P. Let's write first, not Q, not P, and not Q implies not P. It should be so the opposite is one is comes to this part. So this should be F, T, F, T, and this opposite of P. So an opposite or negation of the P, F, F, T, T. So this one is this guy here. So you can complete this one. So from Q implies to T, so you can complete here, and you need to show that this column is equal to this one. So as a result, you can conclude that this one is like the same truth table, same value. So as a result, these are equivalent. Now let's do the part B, which you had the similar question in your assignment. Can I see the assignment? It was like question 2, part B. So question 2, question 2, part B, assignment. So it's like this one. So the solution is like same as this one. So for this part, so because you see that we got this one, we need to say this part. Let's say P is X belongs A, Q is X belongs B. As a result, A, so can I add more pages? Yeah, A, so let's write here, A subset of B is like, this is equivalent to say that means X, if X belongs A, implies it's the meaning of A subset of B is this. So if we take any element, any arbitrary element from A, which is subset of the set B, it means if I take any element from A, it implies that that element is also belonging to set B. From here, we see that X, so X belongs to A is this guy, implies the same thing. Therefore, X belongs B, which is Q. So we got P to Q. But from part A, P, Q is equivalent to say that Q implies this guy. From here, so from negation Q to negation P, we can say that we have X not belonging to B implies X not belonging to A. So which is equivalent to say that X belongs to B complementary subsets. So it means, so complement subset, complement of the A implies X belongs to A bar. This means B bar is this guy. So similarly, you can prove the other way around, like from here, you can start from here and get this one. So I encourage you to do this part by yourself. So I won't write from here to here. In the exam, actually, I'm not sure if you write one of that. If you have something like this, if you write one way, it will be acceptable, like qualify to get full marks if you don't write this one. So to say that, like, similarly we can do this, but I would better be conservative and write both side of the equation, both side of the implications. All right, now let's do the number theory questions, which we had like a few weeks ago, the similar question. Now part A is this guy. So we see that using the Euclidean algorithm. So we have that 273, which is the quotient is 2 times. So I write the quotients first, divided by 110 plus 53. From here, 110. So we will continue this divisions as long as we get 0 in the remainder. So 110 is equal to 2 times 53 plus 4. So then after 53 divided by 4, which is like 13, 52 plus 1 here. So finally we got this one for sure. 4 divided by 1. So we stop here. So the GCD of 273 and 110 is equal to the last non-zero remainder, which is this guy here. All right. So now let's have a look at the part B. Actually, this should be part B. All right. So to do this one, let's do in this way. So we wanna do part B. So 110x is equal to 5 in the world of the mode 273. So I'd like to find x, and to be able to find x, we need to multiply both sides of the equation by something such that x will be subject or x will be alone. In other words, so I wanna times the left hand side by this 273 such that a times 110 will be 1 in the mode 273. So we got this one. So this one, which is equivalent in the definition of the mode, is like a times 110 minus 1 equal to k times 273, which like a and k are the integers. So in other words, this one, a times 110 minus k 273, which is equal 1. So I want to get this one. But we see that the GCD, another definition of the GCD is like, if we are able to write the GCD of the 110 and 273 as the linear combination of the with the coefficients of from the integers a and k. So GCD is 1, so it is the same as like that linear combination that I mentioned. So to be able to get that linear combination, we can use this part, which I have written it here. So maybe I can cheat. So can I get this part, a copy from here? So let's copy this one. So I'll get this one here. So now here is the thing. So 1 equal to 53 minus 13 times 4 from here. So I'll use the second equation. So instead of 4, I will use 110 minus 2 times 53. So I got 53 minus 13 times 110 minus 2 times 53. Can I simplify this? So minus 13 times 110. I'll have to 26 and that 1 plus 1, which will be 27 times 53. All right. So now from here, I'll use the first this equation here. So instead of 53, so minus 13 times 110 plus 27 times 273 minus 2 times 110. So from here we can write 27 times 273. So this guy is minus 54 and minus 54, and we got another minus 13 here. So together will be minus 67, minus 67 times that, yeah, 110. So you see this guy, this one here. So we needed this one. So we needed this to obtain this guy here. So what we want to do, we will multiply. So we needed this one, minus 67. So 110, rewriting the equation in equal to, what was that? So 110 x equal, yeah, I remember now, mod 273. So I multiplied by 67 times 110 times x minus 67 times 5 in the mod 273. So this guy is 1, because what we discussed. So x will be, so minus 300 and minus 335 in the mod, what's that, 273. So we should better to have a positive integer here. So I can write this one as minus 1 minus 3 under 35 minus something equal to minus 2 times 273. So this will be 614 minus 546. So this will be, so x will be, what's that? 546 minus 335, which will be mod 273. So can I do this? So this will be, as a result, x will be 235.11. So mod, okay, mod 273. So I hope I didn't make a mistake in my calculations. So it is here. Okay, so you will, anyway, you will check and you will do these questions by yourself again, but it is like this. And don't be confused with the quotients. So I write the quotients first here. And when I get any, like the dividee or denominator here, 110, so I will write the denominator here. 53 comes here, 4 is coming here. Actually, you can stop your algorithm when you get remainder 1, because obviously the other one will be 0, and like this. So in order to get this 1 to be equal like this, I used from here, using this equation, then this equation, then this equation. All right, so This is the first video, and I will make the other video for the rest of the questions.